This lesson is over quadratic formula. When it comes to quadratics, we know how to solve by factoring, solve by using the square root property. But what if the problem cannot be factored or cannot use the square root property? Well, the good news is you can solve any quadratic equation of the form ax squared plus bx plus c equals 0 by using the quadratic formula. The quadratic formula is represented as x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's look at an example. Example 1. Solve. For a, we have x squared minus 8x plus 5 equals 0. Looking at the equation, notice we have x squared and x, so our equation needs to equal 0. Lucky for us, it does. So to solve this, we have several methods. We can try factoring, but if it doesn't work, then we need to try the quadratic formula. So let's try factoring. Since we have 3 terms, we will try the AC method. So 1 times 5 gives us positive 5. We create our list of multiples. 1 times 5 is the only option. Now we look at the sign. Since it's a positive 5, that tells us that the values must add to equal the middle number, negative 8. Well, from the list, 1 plus 5 will never give you negative 8, which means this cannot factor. So we must use the quadratic formula. To use the quadratic, we must identify our a, b, and c values. A is 1, b is negative 8, c would be positive 5. Now that we've identified the values, we're ready to plug them into the quadratic formula. You must use parentheses. Take the time now to plug in the appropriate values. Now that the values are plugged into the formula, we need to carefully simplify. Out in front, we have what looks to be the opposite of negative 8, and the opposite of negative 8 is a positive 8. Under the radical, we have exponents, multiplication, subtraction, but remember, you have to follow GEMS or order of operations. An exponent comes first. Negative 8 squared means negative 8 times negative 8, which we know is 64. And in the bottom, we have 2 times 1, which we can confidently write as 2. So although we have simplified some, we haven't done it completely. We still have more operations under the radical. According to GEMS, we have to do the multiplication next. Negative 4 times 1 times 5 gives us negative 20. Now we can see under the radical, all we have left is subtraction, and 64 minus 20 is 44. Since we have simplified under the radical, now we actually look at the radical as a whole. We need to see if that can be simplified. The best way to do that is to do a factor tree and factor 44. If you factor 44, you will get 2 times 2 times 11. And notice, we do have a set under the radical. We have a pair of 2's, so those can come out of the radical, giving us 8 plus or minus 2 square root 11 all over 2. From here, we deal with the plus or minus, which means we have 2 different solutions. For the plus version, we have 8 plus 2 square root 11 all over 2. Since the numbers in the numerator are not like terms and cannot be combined, we need to separate them. That gives us 8 over 2 plus 2 square root 11 over 2. Now looking at them individually, notice they do reduce. 8 over 2 turns into 4, and 2 square root 11 over 2 reduces to leave you square root 11. The 2's reduce because they are outside the radical. So that is your first solution. Now the other case is 8 minus 2 square root 11 over 2. Notice in the numerator those are not like terms, so we cannot combine, which means we need to separate. When we separate, we get 8 over 2 minus 2 square root 11 over 2. Look at them individually and notice they do reduce. That gives us 4 minus square root 11, and these are your solutions. For B, we have x squared minus 4 equals x. Notice this equation has x squared and x, so the equation needs to equal 0. Currently, it doesn't, so we need to subtract x on both sides. That gives us x squared minus 4 minus x equals 0. So it equals 0, but is it in the correct order? No. You need to take the time to reorder them. So it should read x squared minus x minus 4 equals 0. Now that everything's ready, we're ready to now attempt to solve. We could try to factor, but if that doesn't work, we can do the quadratic formula. Let's try factoring. Since we have 3 terms, we try a times c, which would give us negative 4. We create our list of multiples, and then we look back at the sign. Since it's a negative 4, that tells us the values will subtract to equal the middle term, which is negative 1. Well, in your list, 1 minus 4 will never give you negative 1, and subtracting 2 and 2 will never give you negative 1, which means we cannot factor this particular equation. So we need to do the quadratic formula. To do that, we need to identify a, b, and c. A would be 1, b negative 1, c negative 4. From here, we get the quadratic formula prepared with all the parentheses, and then we carefully plug in each of the values appropriately. From here, we simplify. Out in front, we have the opposite of negative 1, which gives us positive 1. Under the radical, we need to address the exponent. Negative 1 squared is negative 1 times negative 1, which we know is a positive 1. And in the bottom, 2 times 1 is 2. Now, we still have more operations under the radical, so according to GEMS, we need to take care of the multiplication next. Negative 4 times 1 times negative 4 is a positive 16. Now, the last operation under the radical is to do addition. 1 plus 16 gives us 17 under the radical. Since we've simplified under the radical, now we want to see if we can simplify the radical itself. Can 17 factor? No. Which means we are stuck at 1 plus or minus square root 17 over 2. But we need to separate that plus or minus. We will have the plus version and the minus version. Looking at the plus version, since we have 1 plus square root 17 over 2, notice 1 plus square root 17 are not like terms, so they cannot be combined, which means we need to separate these. That gives us x equals 1/2 plus square root 17 over 2. Now look at those fractions. Can either of them reduce? No. So that is your first solution. Now we look at the minus version. Again, 1 and square root 17 are not like terms, so we must separate, which gives us 1/2 minus square root 17 over 2. Again, those cannot reduce, so these are your solutions. For C, we have 5m squared plus 3m equals 2. Now notice we have an m squared and an m, so the equation must equal 0. Does it currently equal 0? No. So we must subtract 2 on both sides. Now since it does equal 0, we check the order. Lucky for us, it is in the correct order. So now we check. Can we solve this by factoring? Can we use the quadratic formula? So I'm going to give you a moment to try to see if factoring works. Now if you found factoring to work, great. If not, then let's go ahead and continue with the quadratic formula. We would identify our a as 5, b as 3, and c as -2. From here, we would have plugged the values into the quadratic formula, and then we would simplify. Now notice, this is not an x. This time our equation involved an m. So when you're writing the quadratic formula, in this case, it will be m equals da 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 da. So make sure you're using the correct variable. So in front we have m equals, and it'd be the opposite of 3, which is a -3, plus or minus 3 squared, which we know is 9, minus 4 times 5 times -2, all over 2 times 5, which we know is 10. Now from here we have to take care of the multiplication under the radical. And so -4 times 5 times -2 gives us a positive 40. Again, under the radical, 9 plus 40 combines to give us square root 49. Since we've simplified everything under the radical, now we want to simplify the radical itself. You may recognize the square root of 49 is actually 7. And so this has simplified to -3 plus or minus 7, still all over 10. So from here we want to separate and look at our plus version, which would be -3 plus 7 over 10. And we need to look at our minus version, -3 minus 7 over 10. Now in the numerator, -3 plus 7, are those like terms? Yes, which means you do want to combine your numerators. -3 plus 7 is a 4, still all over 10. Now since this is a single fraction, we want to, if possible, reduce the fraction, and it reduces to 2 over 5. So that is your first solution. Now your second solution is of the form -3 minus 7, and again, those are like terms, still all over 10. Well, -3 minus 7 combines to give you -10, still over 10, which can reduce to give you m equals -1. And these are your two solutions. Now, if you were able to factor earlier, you too should have gotten the same solutions of m equals 2/5 and m equals -1. Either method would have worked on this particular problem. Example D. A squared minus 4a minus 8 equals 0. This is your triad problem. Let's see how you did. Hopefully you found a equals 2 plus 2 square root 3 and a equals 2 minus 2 square root 3. For E, we have 4x squared plus 3 equals x. Notice the equation. We have an x squared and an x, so our equation needs to equal 0. Currently, it does not. So, we need to subtract x on both sides. We have 4x squared plus 3 minus x equals 0. So it does equal 0 now, but is it in the correct order? No. So you do need to make sure that they are in the correct order and rearrange as necessary. It should be 4x squared minus x plus 3 equals 0. From here, we can try factoring. If factoring doesn't work, we try the quadratic formula. So for factoring, we do the AC method, and so 4 times 3 would give us positive 12. We create our list, 1 times 12, 2 times 6, 3 times 4. Now we go back and look at our sign. Since it was a positive 12, that tells us it has to add to equal the middle number, which in this case is negative 1. Now whenever it says to add, it means the signs will be the same. Either the values are both going to be positive or they're both going to be negative. Well, 1 plus 12 will never give you 1. 2 plus 6 will never give you 1. 3 plus 4 will never give you 1, which means this cannot factor. So we're left using the quadratic formula. So we identify A, B, and C. A will be 4, B will be negative 1, C will equal 3. From here we plug the values into the quadratic formula. So x equals negative, plug in your b, which is negative 1, plus or minus the square root of negative 1 squared minus 4 times 4 times 3 all over 2 times 4. Again, make sure you use parentheses. From here, we want to simplify. In the front, the opposite of negative 1 is a positive 1. Under the radical, we must deal with the exponent. And so negative 1 squared is negative 1 times negative 1, which we know is a positive 1. In the bottom, 2 times 4, well, that's 8. All right, now we need to look under the radical, and we need to take care of the multiplication. Negative 4 times 4 is negative 16, and negative 16 times 3 is negative 48. So the multiplication results in a negative 48. But we still need to now do subtraction and addition under the radical. 1 minus 48 is negative 47. So now that we've simplified under the radical, we need to simplify the radical itself. And what do you notice? Well, there's a negative under the radical. When you have a negative under a square root, what letter just got introduced? Well, that would be I. We are now dealing with an imaginary number. So we've taken care of the I, and if you were to try to factor 47, it turns out 47 is prime and cannot simplify, which means we are now ready to look at our plus version and our minus version. For our plus version, we would have 1 plus the square root of 47i all over 8. The minus version would be x equals 1 minus square root 47i all over 8. Now notice in the numerators, 1 plus square root 47i, those are not like terms, so we must separate them and write it as x equals 1/8 plus square root 47 over 8i. And neither of these values can simplify, so that will be your first solution. For the subtraction version, the same thing is true. We must separate them, and we get 1/8 minus square root 47 over 8i. Now keep in mind, because the solutions are made up of real and imaginary, these are complex numbers, and we must clearly be able to see the real part and the imaginary part. So you must separate them.